rate to 250,000 to try to get the reflecting shockwave off the table.
With a set number of frames we can capture, the faster we capture them per second, the less time we have to record.
There we go.
Oh my goodness. You see how quickly it's thinning out too from the inverse square law.
As we get over 1 million frames per second, our record time is far less than a millisecond. And at a maximum of 20 million, we have to get our timing dial to just 12 microseconds. This is a challenge that we'll have to address throughout this entire video.
Super cool. Awesome. Okay, you want to try to up the frame rate now? Hit 1 million?
Go. 3, 2, 1.
So crisp. So loud. Look at all those little starfishes coming out, the little pieces of cardboard. The explosion isn't perfectly instant across the whole material. It's a spreading shockwave of detonation. So we're getting little pockets of explosion. Well, I don't think we're going to gain much more by going to 2 million because that's pretty slow.
Shot I came up with a while back that I wanted to see in action. We've got the squib here right at the foci of this ellipse. And the shock wave, as it expands out and reflects off the ellipse, should come back into focus right over here where the other foci is. I don't know, think it'll look pretty cool watching shock waves bounce though.
Yeah, and this is the only way we could visualize it is with Schlieren. So you're saying any spherical propagation from this point should all reconverge right back over
And
here.
come right back into a sharp focus there.
Is this theory or is this going to work?
No, that'll work.
Okay.
I think so.
Cool.
Everyone's ready? 3, 2, 1.
Little bonus shot. Watch physics in action. Look how clear that is. And dink. Right there, right on the edge. That's so cool. This is why you go to geometry class, folks. Beautiful.
Okay, so we are moving from the large squib load all the way up to a blasting cap.
Which is not what that is.
No, we're waiting on our explosives expert to get here to swap it out. And over the last 48 hours, I have been getting lobotomized with talks of nanoseconds and microseconds.
That's a good word.
Like all sorts of stuff. So can you bring this into the ballpark that anyone watching this can understand how fast are you talking?
Well, the common phrase is blink of an eye, right? The blink of an eye is usually on the order of hundreds of milliseconds, right?
Okay.
The explosion time, detonation, is usually on the order of tens of microseconds.
Okay.
So we are 4 orders of magnitude, an order of magnitude being 10 times.
Okay.
Shorter of a time scale than the blink of an eye. So it's 10,000 times we have funneled into time to get down to microseconds.
So by the time I blink, that could have happened 10,000 times
or more, just depending on, you know, when do you classify the explosion, right?
I hear the experts rolling in now, so we're gonna get this wired up and start ramping stuff up.
Sounds good.
You're gonna do the fire in the holes, yeah?
Be on this side, make sure you can't see that. Ready? Yep. Fire in the hole! Fire in the hole! Fire in the hole!
Oh, that was way louder.
Everything triggered. We missed it. We missed it. We missed it. We missed it. We're gonna have to do another one. The blasting caps have a longer inherent delay to blow up from a trigger time than those squibs did, so the Shimatsu didn't see anything. So that's why we have the TMX camera. The TMX records for many seconds, so we can see from trigger frame to when it detonates what that delay is, and then reduce that delay and reprogram it into the Shimatsu. So we're just gonna have to go again. Going hot! Fire in the hole!
Ooh.
So fun.
This is one of those things, like there's nothing to see until the cameras are done.
Yep, we got it. We got it. Look how the other photogenic is lighting up the gas. Watch the top of the blasting cap. So you see a bulge?
Yeah.
You can see it wrinkling up.
Oh, yeah.
So you have the inertia of the metal trying to get shoved out, but since all the explosion is released, all we have is just energy pushing up. And it's like a soda can just getting crushed. I did not think that that's something we would see.
That is freaking wild.
This looks like a chandelier of death.
And what frame did you run this at?
This is about $500,000.
$500,000. Nice. I didn't expect it to go off at that end first.
Yeah. First frame would have been that.
First frame would have been this.
So now we could cut out like 40. Where is it? Oh, peak brightness is perfect. Someone else want to do the honors?
I'm playing with my pickle.
You want to do it?
Can't let you have all the fun.
All right. On you.
All right, going hot. Fire in the hole. Spicy.
Let's go take a look. The camera's blown up.
Did you feel it in your bones? Is it perfect?
You know I did, I just didn't want to say it.
You just didn't say it? Okay. I don't know if it counts then. Oh.
Oh my
God.
What? Goodness.
Wow.
Go back. I gotta see that again. Oh my goodness.
That is wild.
Look at that. I don't know how to describe that. That massive smushed air propagation. It's so multi-layered and
It looks like the old nuke.
Yeah. It's actually kind of cool, like how much that holds it together.
that's nuts.
Dang. Good job, guys.
Now I just wish that was actually an atomic bomb.
Yeah, we'll get there.
We'll get there.
We'll get there.
At this point, we wanted to remove the Schlieren setup and get our photogenic strobe lights in as close as possible. We can then put a macro lens on the Shimatsu and crank our frame rate well over 1,000,000 to see just how these things detonate.
Who's detonating?
Yeah, there you go. Yeah.
Fire in the hole!
Why does it seem louder every
I don't
time?
know.
Oh, dude.
Yeah.
So, because all of that happens in here, we could easily do 5, maybe 10 million.
Don't get ahead of yourself, Bryce.
Go back to the beginning and do frame by frame. Oh yeah, that's good. Okay, so we could probably get lights closer, exposed down even more.
Get in closer on it with more tubes if you want. So if you want more zoom on that, like we could just fill the frame with that.
Yeah.
We got enough light.
Okay. We only use like 25% of our RAM before it's just dust. Let's do 5 million.
Do you want to hit it, Lexi?
Yeah, let's let Lexi do it.
Yeah.
Ready?
Yep.
Fire in the hole!
It's mid-explosion. That would have been perfect.
I didn't take anything off of that.
Go back to the first frame.
Oh, did we lose it?
Look how close we were.
Oh.
Despite how insanely accurate our electronic timing is for the lights, the camera, and the action, we're starting to realize that there comes a point where some things are just outside of our control. The blasting cap itself. This basically resulted in a game of cat and mouse for most of the night. A problem that we fully realize and solve the next filming day when we explore Detcord. But for now, to finish off night 1, we back the frame rate off from 5 million down to 3 to press our luck one more time.
I feel like a superstar, all these lights.
Oh my gosh, is that Bryce from Ballistic High Speed?
Bang! Ready?
Yep.
Fire in the hole! Fire in the hole! Fire in the hole! I feel it in my bones.
Dude, that's gotta be it. That was too gangster not to.
Too gangster.
That's too gangster.
Please work. Please work.
Yes! Alright. Good job, gentlemen. Good job.
That was so good. Okay. We could have done 5 million.
I know.
All right, go back to the beginning. Oh, it's so good. Look at that stretching. You're actually getting the metal spreading thinner and thinner until it reaches its shear point.
Yeah. How cool is that?
Go back to when it starts. Your bridge wire got hot. Your primary went off first. You see the bulge of it. Now, watch as it continues. Okay, now it's going to your main charge.
I see.
There it goes.
So what is all of this?
Nothing.
Just empty
Oh,
tube
Empty
collapsing.
tube, yeah.
So we literally are seeing an empty cylinder crunch.
Yeah. I've never seen it that detailed and that slow.
It's 1/3 millionth of a second from that to the next.
And I mean, that makes sense.
333 nanoseconds of difference. Billionths of a second.
Yeah, you're watching a chemical reaction wavefront.
All right, now that we're done with some stuff in the shop, we are outside exploring one of our favorite topics, which is det cord.
So the reason that we were studying all of that is because this blasting cap is going to be used to detonate this det cord. So we wanted to see exactly how they work. Now we're going to hand it over to an expert who's going to help us detonate this so we can capture it at...
We always start low to get timing, so we'll probably be at 500,000 frames per second. It's crazy that that's a low
Yeah,
number.
the low number.
So that way we have plus or minus so we can get timing if something's off a little bit. But ideally, I want to